I'm Paul Chau. I'm a West Point cadet.
I'm Andrew Serrata. I'm also a West Point cadet.
Today we'll be discussing our experience with SCUDEM 2025 and our experience with modeling differential equations. We'll go ahead and get started. Andrew, would you like to start off?
Yeah, sure. So when we were given the prompt, we so we started. Can you go to the next slide? Back, back one. Right. So we wanted to study the concept of mood congruency and figure out how we can maximize the ability of a message to spread and influence behavior. And so reading the data that we found, we came to the conclusion that the best way that a message was received um, was with positive mood. And likewise, dissuasive mood was the best way to dissuade a message. And so that was the initial assumption that we made going into the model. And so those were the two different kinds of messaging that we compared with our model itself.
So we proposed a double SEER model because you have two different types of movements. You have positive persuasive messaging and negative dissuasive messaging. So a SEER model basically says, basic fundamental SEER model says that you have a susceptible population who can be exposed to a movement or infections usually used for viruses as a disease, and then they're recovered. We use the SEER model and we apply it to how people are exposed to messaging. So instead of people being infected, they're basically exposed to one of the message types. And it's a double SEER model because, again, there's two different types of movements, one for persuade, one for dissuade. And the outcome of this model is you should be able to see which movement was more successful. Andrew, do you?
Yes. So the model itself, I mean, it's based on the SIR models system. And so we use that double SIR model, and it's essentially rate in, rate out with the messaging itself. And the way that a message is spread or actually gets absorbed by a person is based on those coefficients of spread from the data. And the parameters that we had um, measures how quickly a movement disseminates throughout the population. Intent is how likely an individual is to comply with the movement's goal once exposed. And then cross action is how likely an individual is to deny a movement's goals and instead comply with the other movement. So essentially, if a person hears a message and they decide they don't agree with it, they're automatically put into the opposite group. And so once you're actually exposed to a message, either listen to it or you don't. It's not like there's a situation where you're not one or the other. So closed system, neutral mood, complete exposure, and complete intent, and binary selection.
And when we solve this in Mathematica using ND solve value, we got um, this resulting graph. If we interpret this a little bit more, you'll see that basically here in red was the population of the persuade movement. As you can see, population of 83,000, and then here in the sway movement, 17,000. And interpreting this, we can see our model is reasonable because we can see the population stays at 100,000 throughout the entire time frame, because means we have a closed system. And we can see here the decreases in the susceptible population are matched by increases in the exposure population. That is, as this decreases, you'll see that these two, the yellow and the green, increase because people are moving from basically the general population to being exposed to one of the two movements. Likewise, decreases in the yellow and green are matched by increases in the red and purple because as people are moving from being infected to recovering essentially or being at part of the persuade dissuade action.
And so based on that, we managed to get these statistics, and we concluded that positive persuasive messaging is more effective at not only spreading but also influencing behavior. So it spread throughout a population better, but then it also attracted more people to actually accept the rumor or go with the rumor. And based on this model, we can improve having actual data points, which will allow for recalculation of parameters fitted to actual values. So the data that we were given was very limited to that specific study. So if we had better data points fitted to real world parameters, we could refine this model for a more real world use. And I think our assumptions are probably what also hinder the accuracy of this model. So if we could figure out a way to better fix those assumptions or better define those assumptions, then again, we can make this model, we could improve this model.
And yeah, like my partner just said, like all the SCUDEM prompts, the studies that were given to us, the data given only allowed us to calculate the parameters. The next step for us would be to conduct a real world study and refine these parameters. That concludes the presentation in terms of the actual model. But we'd like to transition to talking about our educational experience about this and our experience overall with SCUDEM. I'll go ahead and start off, and then I'll move to my partner, and then we can open up to some questions. So for me, I am not particularly a STEM individual. I have been more focused in the humanities all my life, but having the opportunity to do SCUDEM, especially with this particular prompt where you're basically taking something in sociology or in psychology and applying it through differential equations, I found it very gratifying because as someone who's been interested in humanities all his life, seeing the application of something like STEM that I felt disconnected with, it opened my eyes on the potential that this field holds and what future study of it could bring about. Andrew, do you have anything?
Yeah, so I thoroughly enjoyed the challenge that the problem brought. Um, the the study itself and the information that we were given, I think gave us it gave us a unique challenge to where we had to use a lot of our own background information, what we learned from our course, and run with it to create this model. And I personally didn't have much experience, or any really, with creating differential equations before this project. And I think it offered a unique challenge and a unique way to learn more in-depth concepts about differential equations and how to create them, how they're created, and also provided real-world use and application for a lot of the information that we were learning about.
Well, with that said, we'd like to open up the session to any questions about our experience or anything at all, really.